Excuse me. Hello. Welcome, everyone. So, I have gotten some requests for some additional information about the Lab 5 Orbit of Mars lab. So, I just want to take maybe a moment or two and go through the lab just to give you some extra tips, and maybe me repeating certain things will help you out a bit. I was hoping I could find a tutorial online that would be a little bit more straightforward, but I couldn't find one. So we'll just do it this way. Um, I'm going to go ahead and share my screen. So I'm just going to put the lab right up on the screen here. Okay, so the last lab we did, of course, we constructed the orbit of Mercury, and this is a little different. This one is going to be done a little bit differently. So you'll start off, of course, you'll draw the sun in the middle, and then you'll draw a circle around it about 10 centimeter diameter. Now, this circle that you're drawing, this is going to be where the Earth is. So the Earth is going to be somewhere on this line, and Mars is going to be outside of that. Um, if you scroll down, you'll notice that there are two observation positions for each observation. For instance, you've got observation A and A prime here. And so both of these observations correspond to the same location in Mars's orbit of Mars. So if you look at A, here you see that 180 degrees. That's going to be where the Earth is in its orbit. So on your circle, you would start at the sun and then go over here. So that's at about 180 degrees ish. Um, so we'll put the A there. This is not necessarily 180 degrees, but we're going to say it is, right? So you draw the Earth where it is. Okay. And then you've got a second number that says 83 degrees, and that's the angle to Mars. So starting at where your Earth is here, you're going to measure, of course, straight across, we'll call that 0. You're going to measure up 83 degrees and then just draw a line straight, right? You'll just draw a line straight at that 83 degrees. Okay, no problem. And then you'll notice it has its pair observation, that A prime. It says Earth is at 45 degrees. So you're going to draw a position of Earth there. Let's just say this is that angle. And then it says Mars is at 153 degrees from that position. So then you're going to draw a straight line starting at this point from 153 degrees. Boo. Now, what you'll notice is that at some point, the observation lines from A and A prime will meet. The observation line from A and A prime will meet. And the point at which they intersect, that's where you're going to place your dot for Mars, right? Because Mars is at the same place in its orbit during both of those observations. So its relative position in the sky is due to Earth's position in its orbit. So we're going to have a straight line from here and a straight line from here, and they're going to intersect at some point. And the point at which they intersect, that's where we're going to place our dot for Mars. Okay. And of course, again, you'll notice you'll have two sets for each observation. Now, you might be wondering, Mr. Palmer, it says 180 degrees as Earth's position. How do I know where that 180 degrees is? Well, the way you actually do that is here's the sun. You're just going to draw a straight line directly to the right. That's going to count as 0. And so 180 degrees would be 180 degrees measured from there. And that's pretty much it, right? You're just going to, you have two pairs of observations for each position, and there will be a dot where they intersect. And once you've constructed all of those dots, you can just draw a light line that passes through all of them, or maybe a best fit circle, right? It's not going to be perfectly circular or elliptical, but you're, of course, going to do your best on that. And then you got the questions here. It says, what is the length of the semi-major axis of Mars's orbit in astronomical units? Okay, the way we'll measure this is you will have drawn your Earth's orbit at some diameter, right? Let's just say the diameter is 10 centimeters. The semi-major axis of 10 centimeters is, of course, going to be half of that, 5 centimeters. So now now you have a ratio. You know that 5 centimeters equals 1 astronomical unit. Cool. And now you're going to draw a line or maybe measure from the sun to the furthest point in Mars's orbit. Or you could even find the longest part in Mars's orbit and just measure the full line across there. But what's really important is you want to find the average distance from the sun to Mars in centimeters. Let's just say that that distance is 7.5 centimeters. We measure 7.5 centimeters from here. Okay, so we want to use our ratio where we know that 5 centimeters is 1 astronomical unit. Then we want to do some math to see how many astronomical units 7.5 centimeters would be. And in my calculations, that would be about 1.5 astronomical units for Mars's semi-major axis. But of course, you're going to use your measurements to figure that out. Just remember, you know that in my drawing, 5 centimeters equals 1 astronomical units. So I can measure the semi-major axis of Mars's orbit in centimeters and then use the ratio we have to solve for it in astronomical units. Awesome, no problem. It says, what is the eccentricity of Mars's orbit? The eccentricity is defined as E equals C over A, where C is the distance between the sun and the center of the elliptical orbit, and A is the semi-major axis. You'll find the center by using your ruler. And of course, the semi-major axis you measured in part 1. 3 says, what is the closest approach for the Earth and Mars in astronomical units? Well, I can use that same ratio that I measured earlier, where I measured that 5 centimeters equals 1 astronomical unit. I can then use my ruler and measure the closest approach of Mars's orbit to Earth. It will give me some distance. And then I can use the ratio that I have to solve that distance for AU. So these are basically just conversion questions. You're just converting your centimeter measurements to astronomical units. I think that's about it for right now. Just remember, you have 2 observations for each position. Use this diagram here as a helpful point. You'll know you'll have A prime, B prime, blah, blah, blah. You'll draw a straight line from the angle given as the observation, and then you'll just draw a dot where they intersect. Okay. Well, I hope that helps at least just a little bit. And of course, email me with more questions. I don't mind answering questions. If you're struggling with it and maybe you end up turning it in a little late, don't worry about that. I'm not penalizing people right now for late assignments because everything's stressful right now. So just ask me. Let's get it done. Let's work together. Thank you very much for your patience. Have a nice afternoon.